Cool. Going live. We are getting live. We're getting live. We're getting live. And we are live. Hello, everyone, and welcome to meetup number 73 in the Data on Kubernetes community. My name is Bart Farrell, and as usual, it's a pleasure to be with all of you today. If for some reason you have not subscribed to our YouTube channel or you are not following us on Twitter, I highly, highly recommend doing so now. We are very easy to find, very easy to follow, very easy to get in touch with. You can jump in our Slack, happy to answer questions, happy to meet and greet, and always looking for new folks out there to get involved. And speaking of getting involved, we have an extra special way to get involved next, coming up in the next KubeCon in October, where we will be hosting a co-located event, as we did before earlier this year in KubeCon. We're having tons of different talks focusing on the subject of how to be running stateful workloads on Kubernetes, databases, operators, all the good stuff that comes along with that. So if you're interested, and particularly if you're interested in sharing from an end user perspective, very easy to get involved. Like I said, I will share the CFP here in the chat. So if you or somebody in your company has an idea or a concept that you would like to be sharing, please take a look at our CFP so that you can do so. In terms of other stuff, also, like I said, very easy to find on our YouTube channel and elsewhere. You can see all the different upcoming sessions that we have. We've got tons of live streams planned for the next few weeks and even months, all right? Generally doing around 2 to 3 and even sometimes 4 per week. We've got live streams for folks with more experience. We've also got live streams for folks that are just starting out. So always remember that you can ask questions in the chat. You can ask questions in our Slack. We'd be more than happy to get in touch with you. And today, I'm located here in Spain. Maybe we can do just a little quick check. Where is everyone today? I'm going to put this in the chat because it's always nice to get a feel for, one of the benefits of all these virtual events that we've been doing since the pandemic started is being able to connect with people from other countries. And I was actually kind of doing this diversity training today for the Linux Foundation. And one of the things they explained is, some of the strongest organizations are the ones that are able to bring in people from different backgrounds that have different ways of thinking about things. So it's always nice to connect with people from different countries because I feel like it makes you a richer and stronger person in terms of the way that you approach solving problems, the way you can empathize with different people. So anyway, our speaker today is Barak, and I believe, and you can totally correct me if I'm wrong, in Hebrew, does that mean blessing?
No, it's the translation is flash.
Oh, even better. Okay, so starting the first fun fact that we learned today. Thank you very much for the correction on that. Anyway, Barak Amar is joining us live from Tel Aviv. How are you today? How's it going?
Great. Thank you very much. I'm very excited to be here. And it's very hot today in Tel Aviv, and I hope it will get colder in time.
Likewise, for sure. Now, in terms of your experience, everyone kind of arrives at Kubernetes from a different angle, has a different story. In your particular case, when was the first time that you heard about Kubernetes? When was the first time that you started working with it? How did that happen?
So I think it was my passion for open source. I think it was part of listening to all the hacker news and everything that comes out. And of course, every time somebody is taking a Google project and sourcing up something similar outside the company, you, as a developer, you always try to, okay, what it does, why do we need it? Let's play with it. And it was, I think, after I was into containers, and then people was starting to adopt any cluster management systems, then I saw that Kubernetes exists and how you can easily define services and spin up clusters and complete systems very easily. And I don't remember the exact time, but I think it was a long time ago. But like any new technology, it looked like it took a lot of time to get it into production. And I think that still a lot of companies are using Kubernetes, but some technologies are not exactly matching for Kubernetes. Yes, I think this is one of the reasons that Kubernetes is still using a new version and new capabilities for each use case.
Very
my take on Kubernetes also not.
No. But why is yours less valid than anybody else's? I think that the adoption period, that as much as we we're talking about this all the time. So, we're hearing the word and seeing the word Kubernetes every day, but that doesn't mean when you go start knocking on doors in different companies that it might sound like something that's completely foreign. All right. That's very strange. And like you said, one thing is getting started with it. Another thing is really putting it into production. So that's another thing. And then once again, in our community, being focused with data on Kubernetes, and very curious as to how we're going to see this today through, in the case of Treeverse and lakeFS through Kubeflow, is when you first started hearing about data on Kubernetes, how did that go? And what were some of the things that came to mind based on perhaps your experience working with containers, Docker, and other things of that nature?
So my concern was basically because at the time I was working with different kind of databases, is how that stateful state manages, but I think most of the talks were about how software that was built in a time where transition of containers between machines was very hard or not designed to do it. I mean, databases basically was a huge machine or a strong machine that was getting a lot of requests, knows where the data was, know the data layout and everything. And when you taking it into a cluster where everything is transient, basically, it can run on a node and then on a single pod and then on 3 pods and then still communicate the same service and access the same data. I think most of the technologies had to do a small shift in order to adapt to enable the same level of service to run on a cluster like that. And I think most of the engineering that was done when Kubernetes was adopted was in that field. Enable discovery, enable a way to partition the service layer in order to have something run on the cluster and still work without any downtime or losing data. This is the way I thought, at least when it started.
And once again, I think everybody comes at it from a different perspective based on what they've been doing in the past. But as you said, a lot of the things that we talk about in our community, the sort of initial approach of Kubernetes, coming from Borg, coming from Google, then once being released, and there's major focus on it's not designed for stateful workloads, so let's just keep everything statelessly. I'm realizing the introduction of new features such as stateful sets, I believe in version 1.5, and then from there further advancements that have been taking place and giving shape to Kubernetes, creating those other opportunities. And like I said, we're doing session number 73, so we're seeing more and more folks that are able to share these experiences from lots of different companies, lots of different end users as well, whether it's in healthcare sector, e-commerce, retail, financial services, IoT, lots of different areas. And so seeing that this can happen, the benefits, one thing is the what and the how, and the other one is the why, of course. And seeing those, like I said, those 3 questions, that gives us more confidence that this is something that is here to stay and is only going to grow. So with that in mind, can we jump into what's going on with Treeverse and lakeFS?
Sure. So you want me to share the screen?
Perfect. And if you want, you can just give us a little bit of background about what Treeverse is all about. You said you've been there for 1.5 years. It's around 2 years old. Maybe just a little bit of background about how that got started.
Yeah, so it was, I think, at the beginning of the pandemic, and I was security company, web security, and I was looking for something new to do. And then I met one of the founders, and he told me about that project that is planning to do. The idea of Treeverse was to build a project that will help and build better data lakes by filling the missing gaps when you are working with object stores, and having options to manage your data as you manage your code. But I think I'm heading myself before my presentation, so maybe I'm
sure we'll get to that we'll get to that in time.
But for me, it was something new. I like I like challenges. So open source, it's first time for me in working in an open source project and working with data lake. Previously, it was security and enterprise scheduling. I did a little mobile, and a lot of years, a lot of languages, a lot of frameworks, a lot of distributed systems that I worked on, and it was a good match, and it was until now a very good ride for me.
Very good. Cool. Well, let's check out your presentation. And just as a reminder to folks in the audience, you can feel free to put your questions in the chat and we'll answer them accordingly. Perfect.
This is okay?
Yeah.
So, building a reproducible experiments using Kubeflow, and lakeFS. So the main goals in this talk is first tell you about what is Kubeflow and lakeFS, and of course, how lakeFS can help you when you are running a machine learning workflow and you want to have them reproducible. And emphasize that this talk will be more on the data side as opposed to a machine learning side. So if you are into data and issues related to data when you are using machine learning, I think this talk will help you. So what is Kubeflow? Kubeflow is a machine learning toolkit running over Kubernetes. It's a collection of services, or framework, sorry, and tools. If you can see the diagram, there are algorithms, there are monitoring services, there are networking. All of these parts are called Kubeflow as a system for machine learning. We call it system because it helps you in the development stage through the deployment stage. It is used by data scientists that will want to build a workflow, or as an engineer or operation when you want to take the model, for example, and deploy it. I think in previous talk you had Kubeflow served a model as part of the session, and it was done by a single tool inside Kubeflow. And Kubeflow Pipelines is a tool inside Kubeflow that's responsible on running a graph of steps. Each step is a single instance of a component in the Kubeflow pipeline, and that can execute a single step or anything you can containerize. For example, in the workflow, it's called component because you can include a set of inputs and set of outputs, and of course the dependencies between them, or you can condition the output and have a set of steps that while running them, you will have the end result. For example, in machine learning, it can be deploying your new model. In order to have this pipeline, the Kubeflow includes the UI, the one that you see on the right, an engine that executes that model, and a Python SDK that helps you build those steps. And it's very similar to other technologies where they give you SDK in a language you can develop or you can relate in data. Usually it is Python, and also in this case, you can describe the workflow in Python code, execute it, and you get a model in a YAML or in deployment file where you can deploy it into your Kubeflow pipeline.
Okay, sorry, Barak, first question, highly technical question from a highly technical audience member who's Tim Vandekeer. What is the mascot that is at the bottom?
Axolot?
The logo for the company that's at the bottom left, what is that?
It's an axolot. It's a fish that is call it. It's a kind of fish that lives in a lake of. I think it's in Spain, but it's a very cute fish. And I think the idea was that it's living in a lake, and because our project is working on data lake, we wanted something related. I can put a link.
Okay, cool.
Okay,
Yeah, if you
so
put a link here in the chat, I will.
okay.
Very, very good. Excellent question, Tim. Always hitting on the hard technical issues.
Yeah.
But yeah, anyway, crack on.
Sure. So running a workflow pipeline, running a workflow as part of running a pipeline can also have a set of configuration of parameters, and that is called an experiment. And that means that I can run the same pipeline with different set of parameters, and it will be a different experiment. And running experiment over and over again and getting the same results is a very important property. It's important because when you develop a model, or for example, for me, it will be a code. When I take the code and run it 2 times with the same input, I'm expecting the same output. In machine learning, when you are building a model or something that gives you results at the end, something that you can reproduce, you know that you can always go back to the same data set, run the same code, and get the same result, give you trust that the code you develop or the model or the workflow you develop is repeatable. We are not building something that can be created once and then throw it away or deploy it into production and say there is only one of a kind like it and there can never be other. We will need to develop everything from start. We want to be consistent. We want consistency from our pipeline. We want to have trust. We want to be safe, that in case we want to go back and change something, we know that if we didn't change anything, we'll get the same results. Result in a model, it can be something similar, but not the exact, because sometimes, most of the times when you are building models, it's using computation, and there are many challenges when you are building a model. And reproducibility in a model can be structured or depends on 3 core elements: the code you wrote, the environment you executed in, and the data you use to produce the output, the result. One of the problems, one of the many problems when you are using a computation model is that computers are not exact. And when you have an algorithm that's using random or floating point or execute a computation in parallel, some of the results will be different. I mean, if you take them, they are not twins. They will not be exactly the same, but they should produce the same model in how you use it. If I'm checking the model or checking the end result with the same input, I'm expecting to get a similar result. And the idea is to for you to say what is a similar result for the end model. If we go over those elements, we currently use editors and source control for keeping our code aligned. That means usually when I'm deploying a new code into production, I can always have a label saying which commit created or used by the code or the model or the project at that point. In terms of environment, we have Kubeflow, and Kubeflow makes sure that everything is running inside a container and running in the same workflow. That means that I'm using the same operating system for each part, and I'm using the same algorithm with the same version for each part, and running the same workflow at the same order. So the environment should be kept the same. And the data, it depends on how you extract or ingress your data. The data collection phase is always differ between how you work or the company or your data sources. In our case, lakeFS is working on object storage. We see a lot of companies using a data lake to store the data and making sure that the same data is used for each experiment or each workflow usually comes with a set of rules. I want to run an experiment, I will copy the data aside and run my experiment and see the result. If everything will be okay, I will take the data and move it to a different folder, copy it to a different folder, sorry, and then I will have it safely until the model is used in production. And tomorrow I'll do the same until somebody will tell me I need to go back, and then I will look up the folder based on naming or something like that. And there are other ways to do it, and we will see how lakeFS can help with that. So what is lakeFS? lakeFS, in one line, is an atomic version data lake on top of your object store. What does it mean? It means that lakeFS is a thin layer of metadata that serves your object store for all your tools in your company ecosystem, but keeps give you access to the data using S3 interface. That means that if your current tools can access S3, you can point them into the endpoint of lakeFS and continue working with your object store. But that data layer will also provide you a set of capabilities like Git, but on your object store. That means that every time I want to access a branch, for example, I can create one, change something, commit back to the branch, and go back to where I was at the main branch, or change anything like I do with my code. So, for example, if I want to, take the example of our source code and clone our repository, change something, experiment, and commit it back, usually it's an easy task because it's not a lot of data. But in object store, there is the data sets are huge, and the data lake holds a large amount of data, and cloning information or keeping all the objects as part of each branch, like we do in our code, is very hard to do. So lakeFS doesn't move the data itself. It keeps track on the metadata where the data is stored, and can give you the illusion of, or not the illusion, but the view as if it was branched and cloned into your branches or commits. So how it really works. In the API section, that's how you interact with lakeFS, we have an open API, and of course, S3 interface that all the tools can work with, like any other source or any other data source. And the underlying object system can be S3 or Google Storage or Azure Blob, and we have more adapters to work with different underlying storage. The versioning engine gives you a way to commit changes like you commit code, that every time you change something, if you want to branch from it or commit above it, you can just do atomic transaction that will show you all the object changes that was made in that commit. For developers or people who work with Git, it will look very natural, as you can do the same thing you do with your files or sources, but with your data. You get access to all your object store, but you can operate it like any other source control without worrying about anything like we do today, because we can always revert or branch to experiment or pull back the changes by looking at the point you want in your data. So the use cases for our machine learning workflow is, first of all, experimentation, because lakeFS makes it easy for the new tools. For example, you want to run the same code with a different algorithm and check the result. You don't have to worry about deleting anything or overriding anything. You can always create a branch which just point on different metadata without you copying all the data for a different folder. You get the same result. You will get a new branch which would look like the same object store, but without changing the original branch, or the other tools can continue look at the main branch and continue to see the original copy. And if the experiment didn't work, or you don't want anything from that experiment, you can throw this experiment aside, or you can commit the data and merge it back to the main branch. Debugability is another use case where you can now have for me, my source control is also the story. When I look at the code and I want to know what happened, I just check the log, go back, move my environment to a specific commit, and then I check my code there. Now we can do the same at data. We can check the log, we can move to the state the branch was yesterday or before the latest commit and check what changed, or I can roll back to that commit if I want to, which is very helpful to understand changes that are not planned, or at least explained at the object store level and not in a single file. In collaboration, because every time we branch, we get a different working area, you can say of it. It's a branch where you can read and write data. We get a kind of isolation, and that isolation also helps you collaborate in a way that you can take all your incoming data, for example, or incoming all your tools that produce data and keep them into your storage, and have them write it into one branch. And then when they commit the information, all the files will appear in the second branch.
Okay, real quick, we got a question. When adding new data using lakeFS, is there also some kind of git flow then as you create a branch of new data and merge this with the master? How does the git flow or does git flow apply to adding new data?
Good question, because I think I have it in one of the next slide. Basically, you can take the git flow is a practice for anybody in the audience. The git flow practices when I'm working on a feature, for example, adding new code and then merge the feature into the main branch. You can take this practice but apply it into data by saying that I'm branching out from one data source, running an algorithm, or producing data, or changing data in my feature branch, and then I can merge back the changes into the main branch. So this is very similar to git flow. If you can take also, for example, capabilities like verification, you can also say, I want to verify the branch before I merge. So we can also include running tests, for example, or flow or verification before merging back. So this is another use case which is relevant to policies, where we can take extra measure before we changing something in the file system, in the object store, I'm sorry, when we verify changes, when we do it, perform them on a branch, and then we select if we want to merge or not. And the original branch will be kept clean all this time. That answers the question?
I believe so. If not, just keep going. Like you said, you'll be kind of addressing it in the next slide too.
Yeah, so branching and experimenting, this is the use case that is relevant for running machine learning workflow usually. When we want to experiment, we can branch out from our main branch. We can run our machine learning experiment, which can produce many artifacts on the way. And when I'm saying workflow or running a pipeline, usually for machine learning, it is more than one step usually. You're talking about raw data usually that need to be filtered, validated, enriched. You need to select specific sets where you want to verify that the model you build is valid or not. All that usually comes in dataset that you want to make sure that nothing changes at the point you start your experiment. When you are branching out, you do that. It's like a lightweight copy when you are branching for experiments. So when you are running the experiment and you produce output, you can say that running my experiment can be first step, processing the raw data. I can commit the first step. And then, for example, if I want to run two different experiments with the step that I got, I can branch from that point in time and then run two other experiments and check out the results at the end. When I don't have something like Git for data, what we're usually doing is making sure that I'm using different paths, or I'm using local storage, or I'm just running the experiment from the start and make sure that it doesn't overrun other files that I'm producing. And then this is the equivalent part where I don't have to worry about it. Because even if I will override a file or the model in my experiment or in my code, it will be on a different branch. It will not change anything on other branches as well. So users, when we have users that use lakeFS for other use cases, one of the questions they had is how they can integrate lakeFS with their Kubeflow. So we mapped branch creation, commit, and merge as basic blocks that can be used as part of the pipeline in Kubeflow. This is an example of how we integrated it. We use the function-based container ops, and this code is a way for telling lakeFS I want a new branch. And I can show you a small example of how a pipeline works with interaction with lakeFS and try to simulate something similar to what I just said. Any question before we do that?
I think we're good to go. So just jump right into the demo. Let's do it.
Okay. So first of all, a couple of words about what I have right now. I have a cluster with Kubeflow, and I have lakeFS running. In order to get the cluster running, I follow the instruction step by step. It's very easy to do, and this is usually when I'm following the instruction, I'm preparing the same script that I would run again if I need to do it again. So creating the cluster is just producing a YAML file with all my settings and just I'm on AWS, so I'm using EKS. And there, with that description, I created a Kubernetes cluster on my environment. Then you will need a tool called Kubeflow control, which help you define and apply all the changes on the cluster in order to have Kubeflow up and running. It will accept something similar. This is also from the tutorial, from the instruction, the manual of Kubeflow, which I think I edited just the authentication and the region I want the cluster to, where is my cluster. And it will give you an endpoint where you can see Kubeflow. And this is Kubeflow. And before I'll set anything here, we'll see just a second. This is lakeFS. And what I want to do in this demo is make up a story where I want to have a data source, a file. It will include records, and I will commit the data into our repository on our main branch. And then I will run a pipeline with an experiment that will not do anything complicated. It will rewrite the information back as a result. And then we will update the records again on the main branch and run another experiment. That will show you that we can run different experiments while the data source changes in order to see that we are having the results and changes over time. But this time I will do it that each experiment will be on a different branch. We can see the result, we can see the branching in action, and we can see that we can safely update our main repository and look back on the commits. And in order to see the reoccurring experience, we will run a third experiment, and then we will reference the data as it was at the first commit and check that the result was the same as last time. So let's create a repository. Here I'm giving it a name, and I'm pointing the storage nemesis is the underlying storage. Currently, my lakeFS instance works with AWS S3 underlying storage. I will reference my bucket and the name of the main branch. So this is the object view, and currently there are no objects on my repository on the main branch. I will upload one data file, and I will give it the same name, and we'll override it with different records each time. And this is the file I have uploaded. The file is on the branch. I can reference it using our API or using S3. I can, for example, do AWS. You can see my terminal. You can see the file on the branch. The branching is mapped into S3 path like into S3 like a path. So every time I'm referencing a repository, I'm referencing a repository and then the name of the branch and then the records inside. I can commit this change. And we can see the commit logs. And when and each commit is a point in time where I can see all my lake or all my objects in the object store as it was. So let's go back to Kubeflow and run an experiment that will use that file. I prepared one here. So a pipeline example, and this is the Python code. It includes 3 steps. Let's run it. When you are building the pipeline and running the code, you will have a YAML file produced that will describe your pipeline. So I will apply this pipeline into Kubeflow. Pipeline sample, and I will upload sample. And this is a nice graph that we created in our Python code. And here we interact with lakeFS by specifying that we want to create a branch, we want to process the information, do the training in our workflow, and commit the information. The specific workflow will, let's run it. I can pass running parameters to my workflow. So in this example, I will give it the branch name that I want it to create and the source branch that it will use to process the data from or branch from. Hitting start. Sorry, I didn't create an experiment. And let's create an experiment. Start. So we are in the demo experiment and we run it first time. And if we look, we'll see the same graph, but this time it will incrementally build and it will report each step in the running phase. So it created a branch and now it's doing the training part. If we look at lakeFS, we can see that now we have more than one branch. We can switch to the new branch. We can see the original file we uploaded because this branch was branched from main branch. And there is another file called record result. And it also already committed. And in my pipeline, I wrote that every commit will use the name of the branch and changes in the commit message. And if we want to see the main branch, you see that we have nothing from the experiment we are doing right now on the experiment 1 branch. Okay, let's change.
Before that, we got another question. Does lakeFS also interact with a query engine on top to enable SQL-like queries, similar in a like Lakehouse for Databricks?
lakeFS behaves like S3 from any perspective. So if you are using Trino or any engine that can process object store for query engine, the specific tool, I'm not sure if it is on the same use case, it should work. So for example, running Spark over it or Spark SQL and process files in lakeFS, it will be the same as processing them on S3. We do not supply query engine above your object store. We supply the thin layer of the metadata in order to give you the git-like operations, the way you can commit or switch branches for isolation and automacy. Okay.
All right, perfect.
Okay, so let's refresh that because I think it's all green now. Yeah, all green. So I want to simulate by uploading another file with a different data. I'm simulating, for example, data set that all in our organization always updated to the latest week updates, for example. And this time I'm overriding the records on the main branch and I will commit that change. See that it identified that this file was changed. And let's run the experiment again. I'm selecting the experiment. So I'm selecting the pipeline. I'm giving the experiment a name 2, and I'm choosing the demo experiment. And I call it experiment 2. So we'll be waiting for experiment 2 that will process the main branch and produce the result into experiment 2 branch. So now we have 2 branches. With different results. Let's check that we have 2 different results, and I can download it from here. Let's experiment 1. Oh, I have it. Referencing the different experiments. We should get a diff output because we are running the same experiment with different datasets. Now let's run the third experiment. Everything is green. And also that we can see our repository and see for our commits in the main repository, and also on the last experiment, because the last experiment was running from a commit number 2. And now we can run it the third time. And this time I want to reference the data as was at the first day. So let's take the reference of first. And this is the shorthand to commit log, like in Git. It's a hashtag that specifying this commit. And I will run the example pipeline again. Run number 3. I have the demo experiment, and it will be under branch number 3. And the source this time will be the reference to the first commit that experiment 1 was running on. And you can also use Git, lakeFS also support tags. So you can use tags and not hashtags, or you can have the short name, or I can also reference the branch itself. So I can use experiment 1 branch as the source for experiment 3. All 3 will work.
So, got another question. And what about integrity checks? Is there any mechanism to verify that files were not tampered with?
So lakeFS is not the actual object store. We are leveraging the underlying object store. So any operation that you have on the object store, for example, read write. If write completes, it means that your object store wrote the data. So in terms of lakeFS, it will supply the same metadata because it supplied the S3 interface. So you should have the etag record as part of the object record, if that answers the question.
I believe so. Sorry, there's a slight delay, so we always got to wait a little bit. But so, I believe so.
Also, the protocol itself, the S3 protocol, when you upload an object, the signature and the data signature is part of the protocol. So we support the same protocol. When you upload data, it's signed, the S3 protocol. Okay, and oh, what I wanted to do is switch to the latest experiment and download the results. And I want to compare the results from the first run to the results we just downloaded. And they are the same. And that, but basically it's try to explain why we can help by giving you git-like operation on your object store in your reproducing your machine learning workflows, sorry. And we also, if you want to read more or get more information about that project or anything, if you have questions, feel free, jump in, and thank you.
Very, very good stuff. And it looks like someone was started out with a prayer to the demo gods, and it looked like they really, really listened. This is the second session we've had this week where there was a demo. And, you know, it's not every time that things go this smoothly. So very well done, Barak. Very, very well done. Can I get you to stop sharing your screen really quickly, because there's something that we'll have to share before we finish. But also before we finish, just a couple of questions, you know, for folks that are out there and are getting started in all this, because like you said, like, you know, your journey kind of worked in a certain way. What recommendations would you have based on your experience for folks that are getting started out with this stuff? Saying, if I were you, I would definitely recommend taking a look at what first. What would you recommend?
Oh, yeah. Well, it depends. Can you focus on?
Yeah, that's okay. I think, like I said, thinking about. Well, actually, I always have the tendency, because it's something that we haven't had enough sessions on, and because you said that you were previously working for a cybersecurity firm.
Yeah.
So in terms of security stuff regarding Kubernetes, because, you know, we've seen plenty of things going on with hacking for crypto mining. Recently, I believe it was last week or a couple of weeks ago, even the National Security Administration from the United States government, which is not always a major player in this area, came out with a report about how to harden Kubernetes to make it more resistant to attacks. Is there anything just in, you know, entry level that you would say, like, hey, if I were you, I would definitely keep these things in mind?
Yeah, so there are, I think, many best practices, but there are also a couple of tools. But I shout out to companies that work in security and cloud, but for example, Snyk or other company that work in that field specific. It's not the same company that I worked in. It's a different security aspect. I was protecting website versus protecting your organization from attacking. But a lot of the companies, what they are doing is there is the design part and there is the production part. So there are tools that you can use when you design the system or set up your cluster that you need to go over the checklist that need to be addressed before you deploy. Or if something is already deployed, there are a set of rules that need to apply in order to make them more secured versus there are many tools that are already running in production that are there to help you identify attacks that are already there. So I think for a start, it's basically reading the best practices for how to define a secure cluster, how to define your object store right, a lot of role-based policies that need to apply from start. Usually the problem, as I see it, personal opinion only, is that because companies or people start with what's easy to get working first, and then when it's getting to a point where it's too large to manage or to apply those rules, it's too late. So getting the best practices and the same rules or the best practices as first as possible at your organization will help you get your life better later, because a lot of these tools help people that are in a point where they have too much to manage and too much to address, and the tools are helping them. But if you are secure from the start, you are not getting into that point.
It is a really good point.
I see it.
No, I like that. And also because, it's a frequent thing that comes up, like, day 0, day 1, day 2, looking at Kubernetes and it seems, whether it's Kubernetes or lots of other areas, it seems like security is something that's put on, after the fact, not necessarily from the very beginning. And like you said, precisely because I want to click that download button. I want to get things installed as quickly as possible. And I want to start playing around with things. Don't wait until you have a security problem to start taking security seriously. So as you mentioned, there are firms out there like Sneak, like Shippa, like other companies that are addressing this. But I think a lot of it probably comes down to a culture and mindset about taking security seriously. And I think I saw from, shout out to Chris Short from Red Hat, I think he had a post that like the average ransomware payment is now around $500,000. Don't quote me on that, but I saw something like that. Maybe it's difficult to know exactly what the average ransom payment is. But regardless, this is costing companies a significant amount of money. Don't want to make your life more stressful than it already is in the middle of a pandemic. So having those things in mind are probably good. Another thing that I wanted to ask, we did mention Kubeflow. Are there other, tools that are out there that you've worked with that you think might provide similar results, or that you might be able to compare?
So specific running under the cluster with Kubernetes, no, I didn't work with that. In my previous company, we had the production layer handily written in order to have a specific requirements in response time. It was when you have a workload engine like Kubernetes, it's usually very hard to tune to a specific response time, and sometimes in security, it's very, very limiting in the tools you can use.
Okay. So for folks that want to get involved in this, start with Kubeflow. I mean, there's good documentation. It's something that's pretty well tested now at this point. So that's good. That's good to keep in mind too.
Just one more thing. You can also run most of the things, if not all, on your local laptop, because it's a cluster and you can run it locally.
Okay.
It's also a barrier usually when you are talking about other systems where some of the services are available only online.
Okay, so that's another factor to keep in mind. It can be done locally. I guess with that in mind, we're pretty much right on time. So great job getting the demo done, because sometimes demos can be a little bit tricky. But like I said, I think this was very, very solid, well explained from beginning to end. And we got some great feedback and interaction from the audience. Speaking of which, all right, our community is always dependent on the input from our audience, from our users, if we want to call it that. Just as we were starting out in the beginning in terms of how all things got started in Barak's company, about interacting with users and really seeing what they want. We need your feedback. All right, we really, really need your feedback. So I'm going to leave our Google Forms in the chat. It will only take 1 minute. And if you leave your name, we don't need your email address, just your name. You will be eligible to win some swag. That will be announced at the end of the month in our Slack. All right. If you don't want to leave your name, that's totally fine too, if you prefer to remain anonymous. But this is the way that we can see what kind of content you would like to see, what kind of things you learned from Barak's session today, and other things that we can keep in mind as we grow as a community. While we are doing that, we have a bit of a tradition, Barak, that while you were talking, we have an amazing artist. His name is Angel. And let me know when you can see my screen.
Not yet.
Oh, yeah. So while you were talking, he created this as an artistic representation of the different concepts that were being mentioned. So we have a nice laboratory sort of environment. We get the wonderful logo from lakeFS too that Angel also mentioned. I will share this with you in Slack. but there's a rock and roll group from Spain that refers to the name. I think you said axolot is the name of the fish walking, Mexican walking fish is what it's also called. So we'll have to check that out because that's like a little interesting piece of information. But anyway, I thought this was very complete. We got the background on how we got to this point, and then also a very nice demo to seeing it come to life, which you did very well, and there were no issues there, so that's good too. Thank you very much for folks that would like to know more about Treeverse. They're quite easy to find. lakeFS is easy to find too. Any other information you'd like to share, Barak, before we finish?
No, thank you very much for having me. It was very, very nice to share this information with you.
Very, very good. Hopefully our paths will cross in the future. Looking forward to see what's going on more in your space. Also, the other, like I said, the other side of all this is being able to interact with people in other countries. Hope everything continues to improve in Israel as it we all hope that it does in the rest of the world. I feel like we're more kind of together than ever. So sending lots of positive vibes your way, and hope to have you back for another session in the future. Thanks to everyone for joining us. As usual, check us out on YouTube. We're on Twitter. We're on Slack. Always looking for new ideas, new people to join. Barak, thank you very much and have a wonderful evening.
Thank you, Bart. Bye.
All right. Take